Good afternoon all. So today we are going to discuss about temperature above 100 degrees Celsius, and mainly it comes the steam under pressure, that means autoclave. So we have already learned about autoclave in methodology. An autoclave is a machine that provides a physical method of sterilization, and this method comes under physical methods, and how this method accomplish by killing bacteria, viruses and even spores present in the material, which are put inside the vessel using steam under pressure. So this method is based on steam under pressure, that is above 100 degrees Celsius. Autoclave sterilizes the materials by heating them up to a particular temperature for a specific period of time. And here we are using that period of time, that is 121 degrees Celsius for 15 minutes, 15 to 20 minutes. The autoclave is also called a steam sterilizer, that is commonly used in healthcare facilities and industries for various purposes. And this method is considered a most effective method of sterilization because it is based on moist heat sterilization. And there are different parts of autoclave. The simplest form of autoclave is pressure cooker type autoclave or laboratory bench autoclaves. So next we are going to discuss about the detailed description of different components or parts of an autoclave. First one is pressure chamber. The pressure chamber is the main component of the autoclave, and it consists of an inner chamber and an outer jacket. The inner chamber is made up of stainless steel, and it is present inside the outer chamber made up of an iron. The autoclave used in healthcare laboratories, that is filled with steam, is to reduce the time taken by the sterilization temperature. So the size of the pressure chamber, which may ranges from 100, I think some sort of material is missing. Okay, so first important part is pressure chamber. Second one is about lid or door. The next important component of autoclave is mainly the lid or the door of the autoclave. The purpose of this lid is to seal off the outside atmosphere and creating inside the sterilized condition. And the lid is made airtight through a screw clamps and asbestos washer. And the lid consists of various components like pressure gauge, releasing unit or whistle, safety valve. So detailed description are given about the pressure gauge, pressure releasing unit or whistle and safety valve. This pressure gauge is present on the lid of an autoclave. This pressure releasing unit or whistle, which is same as that of the as that we see in the pressure cooker, and it controls the pressure inside the chamber by releasing certain amount of vapor by lifting out itself. The safety valve is present also on the lid of the autoclave. The next coming is steam generator or electrical heater. The electrical steam generator or boiler, it is present underneath the chamber that uses an electric heating system to heat the water and generate steam in the inner and outer chamber. And the level of the water present in the inner chamber is vital, because the water is not sufficient, there is a chance of burning of the heating system. And also, if the water is more than necessary, what happens? It might interfere with the trays and outer components present inside the chamber. Next is vacuum generator. If it is not present in all, if applicable, in some types of autoclaves, a separate vacuum generator is present, which pulls out the air from the inside of the chamber to create vacuum inside the chamber. Because some sort of air pockets inside the chamber might support the growth of different microorganisms. That's why the vacuum chamber is important. Next is wastewater cooler. Many autoclaves are provided with a system to cool the effluent before it enters the draining pipes. This system prevents any damage to the drainage pipe due to the boiling water being sent out of the autoclave. This is the picture of autoclave. Now coming to the principle and working of autoclave. An autoclave works on the principle of moist heat sterilization, where steam under pressure is used to sterilize the material present inside the chamber. So what happens inside? The high pressure increases when the pressure starts increasing, the boiling point of the water also increases, and this helps to achieve a higher temperature for sterilization. The water usually boils at 100 degrees Celsius under normal atmospheric pressure. When the boiling point of the water increases, the pressure also increases. Similarly, high pressure facilitates a rapid penetration of heat into the deeper parts of the material, and moisture present in the steam causes the coagulation of protein, causing irreversible loss of function and activity of microbes. The working principle is mainly employed, that is, the water boils at 121 degrees Celsius at a pressure 15 psi or 775 millimeter of mercury. When this system comes in contact on the surface, when the steam comes in contact on the surface, it kills the microbes. How? By giving off latent heat. The condensed liquid ensures the moist killing of microbes. Once the sterilization phase is completed, which depends on the level of contamination of material inside, the pressure is released from inside of the chamber through the whistle. And the pressure inside the chamber is then restored back to its ambient pressure while the components inside remain hot for some time. So next is the procedure. Before running the autoclave, we should check any items left from the previous cycle. A sufficient amount of water should be put inside the chamber. Now we should place the materials to be sterilized inside the chamber. Then we close the lid and the screws are tightened to make it airtight, and then we switch on the electrical heater. Then we adjust the safety valves to maintain the required pressure. Once the water inside the chamber starts boiling, air-water mixture is allowed to escape through the discharge tube to let all the air inside to be displaced. The complete displacement can be ensured once the water bubble stops to come out from the pipe. Then we close the drainage pipe and we allow the steam to increase inside, and it reaches a desired level, that is 15 lps in most cases. Once the pressure is reached, the whistle starts blowing to remove excess pressure from the chamber. After the whistle, the autoclave is run at a holding period of 15 minutes. Now after the 15 minutes, we switch off the electrical heater and we allow to cool the autoclave. Under the pressure gauge indicates the pressure inside has lowered down to that of the atmospheric pressure. The discharge pipe is then allowed to is open. We allow the entry of air from the outside into the autoclave. Finally, the lid is open and sterilized materials are taken out. So that's about the procedure. Next is different types of autoclave. There are different types of autoclave present in our market. Some of them. Simple type is pressure cooker type or laboratory bench autoclave. That is, it is the most commonly used, which are seen in many parts of the world. And in the most modern type, it has a metal chamber and a secure metal lid that can be fastened and sealed with a rubber gasket. And it has a air and steam discharge tap, pressure gauge and safety valve. And there is an electric immersion heater in the bottom of the chamber. Next type is gravity displacement type autoclave. It is a common type used in laboratory. In this type of autoclave, the steam is created inside the chamber through a heating unit, which then moves around the chamber for sterilization. This type of autoclave, it is comparatively cheaper than other types. Gravity displacement type autoclave. Next is positive pressure displacement type, that is B type. In this type of autoclave, steam is generated in a separate steam generator and that steam is then passed into the autoclave. This autoclave is faster as the steam can be generated within seconds. And this type, it is an improvement over gravity displacement type. Next is we are discussing S-type or negative pressure displacement type autoclave. This is another type of autoclave which contain both the steam generator as well as the vacuum generator. The vacuum generator pulls out all the air from the inside the autoclave while the steam generator creates the steam. The steam is then passed into the autoclave. This is the most recommended type of autoclave. It is very accurate and achieves a high sterility assurance level. And it is most expensive type too. So these are the different types of autoclave: pressure cooker type, common laboratory type autoclave, vertical autoclave, and this both two are hospital type autoclaves. Bottom C. Next we are saying the uses of autoclave. These are important devices which ensure the sterilization of materials containing water. They cannot be sterilized by dry heat sterilization. And what are the different uses of autoclave? It is used to decontaminate specific biological waste and sterilize media, instruments and labware. And regulated medical waste that might contain bacteria, viruses and other biological materials. They are recommended to be inactivated by autoclaving before disposal. In medical laboratories, these are used to sterilize medical equipments, glassware, surgical equipments and medical waste. Autoclaves are used for the sterilization of culture media, autoclavable containers, plastic tubes and pipette tips. Next, we can discuss about precautions. The autoclaves should not be used to sterilize waterproof or water-resistant substance like oil or powders. For this, we are recommending dry heat sterilization or hot air oven. The autoclave should not be overcrowded. The material should be loaded in a way which ensures sufficient penetration of articles by the steam. The items to be autoclaved should always be packed in secondary container. Only autoclavable bags are to be used to autoclave packaged waste. To ensure sufficient penetration, articles should be wrapped in something that allows the penetration of heat. And the materials like aluminium foil should not be used. The items placed inside the chamber should not touch the sides or the top of the chamber. And the wastes and the clean items should be autoclaved separately. Don't mix it. Attempts to open the lid when autoclaving is working should never be made because it leads to some sort of explosion. Liquid components should never be autoclaved in sealed containers. And the liquid inside the containers should only be filled 2/3 of the total volume to prevent the spilling of liquid. Plastic or polyethylene trays or containers should not be used as they might melt and damage the autoclave. Never autoclave flammable, reactive or corrosive, toxic or radioactive materials. The paper should not be placed directly inside the autoclave because it is a combustible substance. It should be autoclaved in a waste bag on a bio bag setting to prevent fire. What are the advantages of the steam over dry air? The steam has more penetrating power than dry air. It moistens the spores because moisture is essential for the protein coagulation, and the steam condensation on the cooler surface which helps in releasing latent heat. Now, what are the disadvantages of autoclave? This method of air discharge is inefficient and it is difficult to decide when the discharge is complete. If the air is not completely removed, the desired temperature will not be attained, and there is no facility for drying the load after sterilization and before taking it out. Now, different methods of sterilization control are mentioning, that is physical methods including to determine efficiency of moist heat sterilization. So, physical method includes automatic process control, thermocouple, temperature chart recorder. Chemical methods include Brown's tube number 1 that shows a black spot and succinic acid whose melting point is 121 degrees Celsius, and this may take place if the sterilization is efficient. Next is Bowie-Dick tape method. It is applied to articles being autoclaved. If the process is satisfactory, dark brown strips will appear across the tape. Next is biological methods. Here the spores of Bacillus stereothermophilus are used as a test organism because it is thermophilic, that is temperature resistant. It can withstand high temperature and optimum growth is 55 to 60 degrees Celsius. and the spores of these organisms require a temperature 12 minutes at 2.